Hi folks, welcome to the first episode from Dragonfly Engineering. My name's Dave Eberhardt, and we're going to be talking about manufacturing in this show. Mostly injection molding, kind of small run prototyping is what I've done in the past. But I'm looking at building build to market consumable parts for folks like you. I'm hoping to see if I can sell this stuff on eBay or Amazon. And yeah, we can develop and build products together. So to do that, I recently acquired a new injection molding machine from Boy Machines, which is a German company. It makes these small to mid-sized molding machines. It's getting a little tight on schedule, so I went ahead and pulled the trigger to buy a second molding machine. This one also has some added benefit of being able to mold more exotic plastics, so we'll get into that pretty soon. But yeah, so I wanted to show you the whole process from not buying, but receiving the machine, setting up the utilities and the water lines and everything, and the bring up of the new tool. That'll be the first episode. The second part of this series is going to be the actual operation of the machine. So I'm going to build a really simple mold just so that we can kind of load it in there to see how it works. And then I'm going to show you step by step how to load the mold, how to train the machine to run the mold. We're going to mold some parts, and yeah, you'll see the whole process from start to finish.
All right, here it comes. That's the new molding machine, the Boy 25 on this flatbed truck. The guy's trying to back it down the alleyway. There's the plane on cue. Let's see how he does. Here we go. Here's my guy from BF&R spray with his forklift, and here's the molding machine. We're able to tuck it into this alleyway. It's not too big. There we go. Let me know if you need anything. I need to get one of these. Or just borrow yours.
This is a good baby right here.
Oh yeah. All right, here we go. Moment of truth. Okay. Yep, you can go down.
I can come in more if you want.
No, there's a machine in the way.
Right
So
there?
this is perfect. There it is. We gotta make this fit somehow. Woo. All right, I'll get back at you soon. Hey folks, all right, so I'm back. Got the machine uncrated here, and I got you on the GoPro, so sorry about the kind of the shaky handheld aspect, but let's take a look at this machine. So for those who are not too familiar with molding machines, this is kind of a small one. It's a 25E, and that's 25 metric ton clamping force, which is about 27 metric tons in the US. And basically what happens is, actually let me close the garage door so you can get a better exposure here. Hold on. All right, I'm back. Yeah, I'm a little new to the whole video YouTube thing, so bear with me. You're gonna watch my learning curve as we go. So yeah, like I was saying, so this is a 27 US ton clamping force machine, and that basically means that you stick a mold in this area, and this platen here, this steel platen, clamps onto the mold and presses it up against the other side of the platen with these hydraulic cylinder rods right here. So this one has 2 cylinders. Normally there's 4 cylinders, but with smaller machines they do 2 cylinders. And then this guy right here, that is the injection nozzle. So that's where the hot plastic squirts into the A side of the mold, and the A side is the side that always gets the hot plastic squirted into. This is an alignment ring that came with the machine. Let me pull this out of here. So basically this ring converts metric to English. So one radius of the ring is 4 inches and the other radius is 110 millimeters. So basically that's how you get US molds to fit on this German-made metric molding machine. All right, so and then in the back here, this hydraulic cylinder and assembly is for the ejector plate. So when the mold opens, part is stuck on the B side of the mold, and an array of pins push the part out of the cavity of the mold. And to actuate that array of pins is this little hydraulic cylinder with this linkage and everything. So that's what actually bumps the part out. Up here we got a couple of hydraulic blocks. These are for hydraulic side core pulls. Some molds have more complicated features where hydraulic cylinders actually press in and pull out undercut features in a part. And so these hydraulic lines are pre-installed to do that. This was an extra option for the machine. So coming out to the front here, this is the control interface, so the computer that runs all of this. There's a safety cage, which you can see is this big guy right here, and it closes and it clips shut, and then the machine won't really do any molding unless this safety cage is closed. And it's a good habit to be in, because this clamp will definitely squish your hand out pretty good with 27 tons of force. And then you open the door like this to service or pull the part or do anything to the mold that you want to do. The parts fall down through the chute down here. And actually this model has looks like a sprue chute, which with like a funnel and a chute. Sometimes you can get a robot to sit on top of the molding machine like we're gonna do, and pluck the parts that you don't want and then throw them away in the chute back here. Let's see, looking at the, so yeah, the display is here. The computer and controls are all inside of this cabinet here. This is the main power switch. Not much to see there. On this side of the machine, here's the hopper. This is where all the plastic is loaded. So you just take the lid off here and you fill plastic inside of there. You can turn off the flow of plastic with this little gate here. And then this pipe is where the plastic pellets drop into the injection unit. So the injection unit's a little hard to see in this machine, but there's this hot barrel with a screw, like an auger screw inside, and basically you melt the plastic and the auger screw advances the plastic forward to a injection area in the front, which is kind of hard to see again. You can't see much under there. And then the plastic squirts out this nozzle into the mold, and then everything repeats. Yeah, so this machine works with a servo motor, which is this motor right here. So basically whenever the machine wants pressure, hydraulic pressure, it turns on the motor and shuts it off when it doesn't need any more pressure. Looking down here in the accessories, these are transformer mounts. there's a little transformer on the back of this machine. I think it runs off of 400 volts and the input voltage is 230, which I started running the power and we're going to finish here pretty soon. This guy is the second injection unit. Let me see if I can get a razor and open this up. So I bought this machine with a large injection unit and a small injection unit. The small injection unit is loaded right now, but this is the larger injection unit, which allows for bigger plastic parts to be made. Let me just open this up so we can see what it looks like. So the smaller version of this exact unit, well, of this style of unit is loaded in the machine right now. But if I can open this up, you can see what it looks like. So again, this is another rotating screw and heater bands to melt the plastic, and it squirts the plastic into the mold. And then back here is the mechanical connection and all of the heater wires and everything. So maybe I'll have to unwrap this a little better and come back to you once I get it completely unwrapped so we can take a look at it. All right, give me a second. Okay, I'm back. I got this thing unwrapped so you can get a better idea of the injection unit for the injection molding machine. Here's the whole thing from nozzle. This is where the plastic under high pressure injects into the mold through this round nozzle here. This is called the nozzle heater, which is a round heater band, and then a bunch of other heater banks to essentially melt the plastic that's inside of an auger screw barrel. You can see down here, this is where the plastic actually comes in. This is sitting right below that hopper, this hopper right here, and you can actually see the screw itself. So this screw rotates, and they put a zip tie on there, but you can see how when this screw is rotating, it's going to advance the plastic into the hot regions of the injection unit. And then back here, this mechanical coupling hooks up to the hydraulic motor and all of the other controls for the machine. So this is the larger unit. This is a high wear unit and a high heat unit, because I'm going to be running some aggressive plastics that some of which have glass fibers filled into the plastic, and others need extremely hot temperatures. That was the air humidifier blowing off, so you'll hear that a lot. Yeah, so these heaters go up to 750 degrees Fahrenheit, I believe, and that's one of the plastics melting temperature that I'm going to be running. So I kind of went all out and got a high wear, high heat injection unit, as well as a smaller one, which is loaded in the machine. You can kind of see remnant, or you can peek through this safety guard to see some of the smaller unit that's in there. Going around the back of the machine, this is a transformer that bumps 234 volts or 230 volts up to 400 volts for the inner workings of the machine. Over here is a cooling line manifold with a brush to clean out all the crap in the lines. Yeah, and of course all the safety switches and things like this. This is a connector, I believe, for programmable inputs, which is going to talk to the KUKA robot, which I'm going to mount at the top of the machine somewhere. I haven't figured that out quite yet. And then, yeah, the back of the machine, wire access, a magnet mount, trouble light, and that's about it. Kind of a pretty bland back of the machine. Let's see. So as far as mounting the KUKA robot, which is probably going to be one of these two, I'm thinking maybe the orange robot, this guy right here, is going to mount onto the machine so it can pluck parts out of a mold in this area. But they made this huge safety guard and safety gate for this machine. I don't know what, they must have designed it for an in-house built robot that would fit inside of this carriage or safety shroud. Usually the shroud comes up to about here, so I'm gonna have to build or weld probably a big structure, like a big tube steel structure, to bring a robot mount maybe at a 45-degree angle about right here, so it can reach over, down, and in and pull parts out and then hand them off to the next robots down the line. But anyway, yeah, so this is the machine. The next step is to move it into the location where the Boy machine service guy is going to hook it up. So Boy Machines is a German company, and they make these small to mid-range molding machines. I've got 2 others, and I'm pretty happy with the results I've had with them. So anyway, we'll have a 3rd one that's running. All right, well, I will show you a little more about moving the machine and running the electrical so we can fire this thing up. The service guy is coming late Monday or Tuesday. So, all right, I'll sign off and I'll get back to you soon. Bye. Hi folks, back from dinner. So now I'm ready to get this machine off of the crate and positioned in its close to final location, which is going to be along through here, through this front door, and right here where this cart is and the dog crate. Obviously these have to move. And you can see how after I cut the back half of the crate off by lifting it with the gantry crane, you can see that the machine is down on the floor on its little coasters there. Here's the little bar that I used to lift, and now the crate is actually tilted up because half of it's gone. So this will actually make life probably a little bit easier. All I really need to do now is reposition the gantry crane to the front of the machine and repeat the process with that cribbing block of aluminum and lifting the bar on the other side, fitting right under the front feet in that gap right there. I did have to raise the lights up a little bit to get the gantry crane to fit underneath the lights. So that took a little bit of doing. I found out what 80 years of machine shop has done to the top of lights. There's about a 1/4 inch of funk up there, old filings and a whole lot of dust. So maybe one day I'll clean the top of those lights. All right, so let me get back at it. I think we'll do some more time lapse, and I'll show you how you move a machine budget style. Hi folks. Well, yeah, so the battery went out on the other camera, so I went ahead and spun this thing and got it back on its trucks. It was a little more difficult than I was anticipating. Needless to say, I'm exhausted now. But the final push is basically to push it to its home, which is in this little room right here. So basically we got all 4 trucks on the 4 feet, and now I'm just going to push it, but I can't hold this camera and push it at the same time, so I'll be right back. Well, I finally got it in there. As you can see, it took most of the day, and it's probably too close for fire exit. But this is a staging ground. Ultimately, I'm going to try to fit it into back there in the clean room against that steel wall. All right, so I got this into the conduit run. So now it's a matter of snaking the wires through the last connection here. These have like a slip coating, so they have a few layers of protection, but I haven't bolted down the conduit yet, but it's got a clip into that unistrut there. So let me, it's a little tricky. Sometimes you need more than 2 hands to do this. One end of the conduit completed. Let me decouple this camera so we can take a look. So I gotta tie down the top of the conduit up at the ceiling a little better. But the rest of this wire is gonna be run through an additional conduit that's gonna come parallel to out of this box and up into the main breaker box. And then, as you can see, let me zoom out.
Our conduit is coming behind that heater and along the top. And down there you can see I haven't finished attaching it to the wall yet, but I'll be doing that next. So the ultimate plan here is to have this molding machine actually reside inside of this clean room / robot work area. So the 35-ton machine, which is there, is very similar to the one I just bought with that robot mounted. I did some measurements, and it looks like what I need to do is move the 35-ton machine against the back wall where that table and microscope and stuff are. The 100-ton machine, which is this guy over here, will stay there because it just weighs too much to move. But I'll probably scoot it against the wall a little bit too. So the idea is that the 25-ton will sit where the 35-ton is, and the 35-ton will be against that wall there. So I'll basically have a molding machine on each wall, maybe with a robot in the middle to tender different machines or trade parts between them. And another little robot similar to this guy sitting on top of the 25-ton, which I'm going to move in here. So regarding the switch, my plan, I believe, is to have the switch disconnect for the molding machine out here mounted on the wall right in this area, and actually move that disconnect switch, which actually powers the 35-ton, out to the same location on the wall. Because when I basically line all the walls in here with molding machines, there's no way to access the power disconnect switch. And again, the fire marshal wants you to have clear access to disconnects. So that switch has got to move, and it's basically going to interfere with the moving safety cage on this molding machine. So for now, for the service guy to hook up everything, I'm going to run this line, this extra power line, which looks like I have plenty, hopefully I do, to a wall location right here to temporarily power this molding machine. All right, so now we're up in the loft area, getting to the final run. We're standing above that new molding machine, and this is where we need to run the wires through conduit along this wall, then drop it down through the ceiling about over there somewhere, even though you can't see it from here. Let me adjust the camera. So yeah, down through the floor, and it's a little tight quarters in here, and it's also pretty hot. But yeah, let's measure out this conduit and figure out where we're going to drop it.
don't know if I have unistrut hardware, so I may actually have to go and buy some or dig around for a while. But anyway, so this is how our switch is looking so far. So this would be the neutral. Blue, black, and red are the 3 hots. And then the earth ground would earth ground is always green, or sometimes it's green with a yellow stripe in it, or it's also just bare copper, because earth ground, its purpose is to pull any hot wires and take that power and dump it straight to ground, with the intention that your circuit breaker will blow, or the resistance of the ground is way lower than your body, so all the electricity would rather just dump into a copper line that goes to earth. I was able to find some unistrut hardware, which should work. You can try to slide it in, but I put the screw in. But the nice thing about unistrut is you can rotate it in as well. You see how you can spin this guy up, and then when you tighten it, it actually locks in place with the little dovetails. So we're going to line this guy up to our hole. And then it fell over, of course. Maybe we should just let's see what I can do here. Alright, let me get that back out. Easy, right? It's a field service trick. Shove your rubber glove through the here, let me do that again. Well, you saw it. So now the screw's in there because a little rubber gasket is stuck inside of the ball socket, and now this thing can be manipulated. Let me Hail Mary here, see if I can get that screw started. I don't think so. I don't feel it. Oh, maybe I did. Oh yeah, it's tightening down. Yeah, so the old rubber glove trick works a lot of times. Hopefully you saw that. If not, I can show you again. I'll check it in post. All right, so we are connected. So the 3 hots terminate right here. Earth ground terminates here. Neutral also, I guess, terminates there. So we can cut these to length. I'm getting low on power. I guess those wire cutters are still on the 2nd floor. So tomorrow I need to go to the hardware store and get the flex cable that will connect to the machine. Actually, I'll probably leave that to the technician because I'm not on my other molding machine. There is a hole right here that you connect in, and I don't really want to dig into this till the guy comes, so I'll probably just get some rubber flex cable with a weatherproof termination that's going to come out the bottom of this switch, and yeah, so that's where we're at. I think this may wrap it up. I may go over and see if there's anything else I can do on the other side, but let's this may be a tentative wrap for tonight. So if not, I'll or if it is, then I'll talk to you in the morning. All right, bye. Hi folks, so we're back. It's been about a week or so since we did the last video for setting up the injection molding machine. And now the service guys come and set the machine up, so I wanted to show you what the disconnect box looks like fully populated. You can see that the 3 fuses are inserted. It's these guys right here, 60 amp blowing fuses. I think they're slow blow maybe, time delay fuses there. Yeah, so there's the three-phase power that we brought in from the little boost transformers and the breaker box at the other side of the building. And then the output, which the service guy for the machine set up, is down here. So you see three hot wires. That's a three-phase, so the black, the red, and the white. Even though the white is typically a neutral color, but in this cable, he used it as a hot. And then the green line, which is the earth ground or the safety ground. Yeah, so basically the safety line connects together. You can see the neutral wasn't used. In a lot of cases with these machines, neutral isn't used. The neutral is basically just a ground reference anyway. So the earth ground can be used as actually a more stable ground reference than the neutral ground. A lot of times in buildings or houses, the neutral does get a few volts on it as it's returning the current from the load in single phase applications. But in three phase, I believe all the current flow is essentially just in the three conductors itself. Yeah, so it's not really used. Yeah, so the earth ground is tied together and tied to the box. I'd like to clarify, I think before I was talking about the needs for earth ground, and earth ground is really only, its main purpose is to make a box safe. So if one of these hot wires gets unscrewed or breaks and then touches the chassis or any of the conduit, then the fact that the earth ground connection is tied to the conduit means that all of the dangerous electricity would rather just go straight to ground through the copper as opposed to a human. So touching this is safe, even if well, I mean, don't do this, but in practice, but the idea is that if one of these hot lines is touching and you touch the box, you're more resistive than the copper. So all the power just dumps into ground and ideally blows a fuse or trips the breaker. Yeah, so looking at the connection line, this is the flex cable that goes to this transformer. This is the transformer again that I said converts the 230 volt three phase to 400 volts for the molding machine. So the connection goes into the machine there. Coming around the side here, actually I can show you an interesting use of earth ground in practice. See that screw right there with the arc flash around it? Well, that was at some point in the past, the earth ground actually did its job. So you can see the grounded case, and somebody hit that guy with a hot line, probably a broken electric heater, and yeah, that's what happened. So instead of frying the person, the power went straight into the earth ground. Yeah, so with the machine, come around to the front. Let me go ahead and turn on the power here. These switches, you can't really turn the power on unless the door is closed, and once the door is closed and you flip the power on, then you can't open the door because it's a safety mechanism. There's an interlock, so you can't actually open this guy. Further safety is if you're working on the machine and you don't want someone to turn it on, you can lock, let's see, how does this, oh, you can lock the switch shut, or you can also lock the switch off. So you put a padlock through this hole when the switch is off, and then no one can really turn on the power to the machine. So it's a good practice, especially if you've got a lot of people working in a place with dangerous equipment, to lock out your power supply if someone's servicing it. All right, coming back over here, switch the power on here, and the machine will come to life. Here's the monitor showing what's happening. Basically a computer's got to boot up. I can't really show you the mold that's in this machine at the moment because it's a customer's mold. So I'll have to basically turn on the machine and close the clamp so that you can't see the IP of whoever owns that mold. But yeah, so looking around, essentially we can just wait for it to boot up and then I'll come back. So while this thing's still booting up, I forgot to mention that it turned out to be easier for the service guy for us to pull the molding machine back out of the hallway here and into this area so that he could set it up better. So it's in a temporary position sort of in the hallway here. I also talked with Boy Machines, and they are going to send me a smaller safety enclosure. My theory was correct that this safety enclosure is for an integrated robot that would fit inside of the safety enclosure. But with us, we're going to put an outside 6-axis robot on. So they agreed to send out a smaller enclosure and swap it out, as well as a couple of hydraulic lines. So in about a week or two, they're going to come back out and do a exchange for the enclosure, so that my little KUKA robot will work on this area. So the robot will mount onto these T-slots. You can kind of see these T-slots here, and then this enclosure will get smaller and move that direction. Yeah, so anyway, oh, well, the machine's booted up here. So I'm gonna do like a second part 2 to this series, because I think this first one is going a little long for the hookup. But yeah, so just so you can hear that it's actually working, we'll turn the heaters on and then turn the hydraulic pump on, and the machine actually is going into an oil warming cycle. We can talk about more of this in the new episode, where I'm actually going to load a mold and then we can run the machine, and I can show you how to fully operate this injection molding machine. But yeah, so I can show you though some of the activity. So if we go to manual mode, and then we can move the injection unit forward and back. Again, the injection unit is a carriage. It has the plastic hot auger that squirts plastic into the mold. So you can see how, yep, let me turn this on. Manual mode. Oh, it doesn't want to go. Hold on. All right, I'm back. Yeah, so there's also safety sequences with this machine. It doesn't want you to do certain motions unless the mold is closed. So this is the mold that I couldn't show you open, but I can show you the closed mold. So this is an aluminum mold that's loaded into the hydraulic clamp here. I went ahead and closed the hydraulic clamp because the machine wants you to follow a strict safety protocol. So now that the clamp is closed, we can move this injection or the carriage unit back and forth. So you can see how it moves forward until the nozzle engages with the mold. We can move it back. And then here is the heaters, which I turned on. We are slowly heating up, but it's going to take forever, so I can't really show you much more activity. But what I can do is show some of the other hookups on the back here. Oh, and by the way, this is the temperature controller here is something I pulled out of a dumpster from one of my old employers. So that's why it looks a little hokey with the nice electric arc right there. In the back here, this machine actually requires compressed air for the safety gate. So this air cylinder actually pushes against a toothed prong safety mechanism, which is this steel bar. You can't really see it when the machine's closed, but we can show you more in the future. And then there's the water lines hooked up. This machine also requires chiller water because there's a feature that controls the temperature of part of the injection unit with by turning water on and off. Yeah, so this is it for the setup. We still need to move it into its final home, but a lot of progress, and I've already run about 3 different parts on this molding machine, so I'm pretty happy with it. Well, that concludes the first half of the machine bring up and installation. Hope you enjoyed the process. A lot of time-lapse video. I'm still working on my video editing skills, so bear with me on that. Yeah, so the next episode is going to be talking about the bringing up of the mold, loading the mold on the machine and running parts and teaching the operation of the molding machine. So if you have any questions regarding like the power or the chiller, I didn't really talk about the chiller too much. We can talk about that next time. Then add comments below, and as every YouTuber says, please like the video if you liked it and subscribe to my channel to see more similar content. So in the next week or so, there's going to be the second half video of new molding machine 2. So I look forward to seeing you then. All right, goodbye.